Software Group. Moving ahead, here is a look at the agenda, a very simple agenda. I will spend a couple of minutes or maybe first 5 minutes to talk about what is Internet of Things. I'm sure it needs no introduction. It's such a hot topic that everybody understands, but folks have got different understanding. So let's really converge on what Internet of Things is. And then I'm going to talk about the IBM offering, which can help you to develop IoT applications. Two aspects to that. One is on-prem. If you want to do something by installing the various software on your machine, how do you achieve that? What all IBM has to offer? And on cloud. So IoT plus cloud, two hot topics, makes the whole discussion very interesting. How can you achieve the same thing with minimal investment? How can you create your IoT application using the cloud offerings from IBM? And finally, I will try to show you, or I will try to create an IoT application online and show you how easy it is to do that using the IoT cloud. Apra is also going to upload the PDF document which captures the exercise. When you go to the document, you can yourself do the same thing which I am going to do today. And if you have got the Bluemix ID, in fact, you can do it along with me. So moving ahead, first thing first, what is Internet of Things? It is, as the name implies, anything, any sensor or actuator or any data communication technology which is built into an object, which you can connect to, from which you can get data, and on which you can take some action, you can send command. Very simple example, you put something in your house, maybe connect it to your geyser, the water heater, and when it's time for you to come back home and you want to have a bath as soon as you come back home from work, just 15 minutes away from your home, you can give a command to that whatever device is going to control your geyser to switch it on so that when you are at home, you have hot water. You can do the same thing with your AC. It's too hot, especially in North India. And if there is electricity there and you want to have your room cooled down before you come at home, you can connect a device or a thing to your air conditioner, and at the right time, maybe just 15 minutes ahead of you entering the room, coming to your house, you can give a command to the object to switch on the AC. Or you could do the same thing, put some sensors to actually measure temperature or the pressure or the humidity or the pollution level and take some action on that. So that's what Internet of Things is, an object through which you can get some data, you can correlate the data, you can do some analytics on top of data, and if needed, you can send a command to that object to control something. Moving on to slide number 2. And first few slides are more business oriented, but I understand that the audience today are developers, but I thought it's pertinent for me to give you a business overview of what IoT is, what are the opportunities there. And in that context, IDC forecasts that by 2040, there are going to be 212 billion installed devices. I can't even imagine what is a billion. So it's 212 billion. 30 billion autonomously connected devices. And most of the opportunity are going to come in public sector, distribution and services, manufacturing and resources, and consumer areas. Approximately 3 million petabytes of embedded system data. I can't comprehend what a billion is. It's very difficult for me to comprehend what a petabyte is, but seems to be a very big amount. And then finally, $8.9 trillion of business value. Some statistic or some forecast from GSMA, a telecom consortium, they define something called connected life, which essentially means anything which is connected. So you put something on your car and you connect your mobile phone with that, your car becomes a connected object. You put something on your mobile phone or you put something on the building, those things become connected objects. Mobile phone are anyway by default they are connected because they can get connected to the internet. But GSMA says that by 2020, The connected life opportunity is going to be 4.5, and connected life here really means the IoT. And there are different aspects to connected life. One is actually connecting your device to the internet, and the other is getting the data, doing some analytics. So connectivity is one part, creating those hardware another part, the opportunity for the analytics software is other part, the opportunity for the telecom carrier is the other part. So all those things combined together, they forecast the opportunity will be 4.5 trillion in 2020. And top 10 for 2020 is connected car, a very interesting use case in which we all are aware of remote locking and unlocking of the car, but you have to be in, let's say, 20 feet within the vicinity of your car. What if sitting in your office and your car at the home, can you lock and unlock your car using a mobile phone? Can you sound the horn, or can you beep the horn, or you can put on the light, flash the light with your mobile phone? So that's what connected car is. Not just that. Can the garage get the data from your car and run some diagnostic tests? Can it be remotely diagnosed? And we have seen this happening in India. The Riva car from Mahindra already has the connected car offering. And this is a big thing worldwide. Moving ahead, I spoke about connected car, I spoke about connected home. So where are the opportunities? Opportunities are everywhere. As this slide shows, there are opportunities with the vehicles, with the meters, with the parking meters, with the vending machines, with the medical system, or with the highways. So opportunities everywhere. The next two slides is going to talk about in a slight detail to give you a better idea of IoT in two spaces. One is smart health. So on the next slide, there are some healthcare examples. And I'll just delve on one in which you install pacemaker in the patient, and the traditional way of thinking is that patient has to go regular visit to the hospital to actually get himself checked up. What if you connect the pacemaker? So you install some device which is able to transmit the data, giving the health of the system or giving the health of the patient to the hospital. So in the hospital, they retrieve the data, and only if needed, they ask the patient to come to the hospital. If everything is fine, there is no need to come to the hospital. So a big leap in the healthcare industry, a big saving for the patient and the peace of life. Next slide. Again, I will cover only one example in the smart energy. The bottom right for remote control of smart home I already covered. So let me cover automatic pipe repair system. Think of a situation in which you continuously monitor the amount of amount of water flowing through your pipe. So there's a meter which can say this is the flow rate. And based on the history or based on analytics, you know that at this time of the day, there's nobody in the house, there should be no flow at all. Or at this time of the day, my flow is only this much. I consume only 10 liters per 5 minutes. What if there is a leakage in the pipe and the flow changes? What is needed here is to retrieve or to fetch this data about the water flow to your house, analyze it, correlate with the historical data, and if you suspect there is a leak, automatically alert the plumber who fixes an appointment with you and comes and fixes this problem in the house. That's another example of IoT. This can be extended. We can keep talking about it, but this was just to give an idea of what IoT is and what are some of the use cases which we are seeing around IoT. Now I'll move to that section of my presentation which will be of more interest to the developer community. Agreed, there's a big business opportunity, but how do I exploit the business opportunity? I have got a big idea. How do I implement that? I'm going to talk about two aspects. One is on-prem and one is on-cloud. And before I talk about on-cloud, I'll also give a very quick introduction to the Bluemix offering from IBM. The whole IoT offering is based on Bluemix. Think of it. On to the next slide. Think of it. If you have got a brilliant idea, an IoT idea, what do you really need to fructify it, to get business value out of it? As the deck says, something you should be able to easily onboard the device, the thing. You should be able to establish a real-time communication with the thing, exchange the data in real time. You should be able to capture the data and store it in the historian database. It's not just any simple database, it's historian database, which means spatial database or the time series database. Once you have the data, provide access to the data, and you should be able to manage the thing. Something goes wrong with the thing or you want to alter the behavior of the thing, you should be able to achieve it. Now there's an extended requirement for the IoT application. Once you have the data, what do you do with the data? Run some analytics, as I was talking to you about the pipeline scenario leakage. Run some analytics to find out whether there is a leakage or not. Then, once you have determined that, or if there is an event, what do you do then? You trigger something which takes care of, which initiates some action. You should also be able to interact with the thing from the business app or from the mobile app. Having seen the requirement for the IoT application, let's see some of the projects from IBM which enables you to develop an IoT application, and I understand this is a very busy slide, but let me simplify it for you. On the left hand side, what it shows that there are sensors in the house. And if you see on the top three houses, there is something called gateway. So all the data coming from the houses, they get aggregated at the gateway level. And on the bottommost house, the fourth house, there is no gateway. Both use cases are applicable. What is this gateway doing? The gateway is collecting the data from the sensors in your house, maybe the temperature data or the humidity data, and various devices in your house, geysers and the washing machines and the dryers, they are connected. It collects all the data and it's able to pass command to these devices. And then it has to pass on this data to the enterprise or somewhere where the data can be stored and analyzed. How do you do that? So all these gateways and the sensors are connected to something called message site. This is an offering from IBM and I'll very quickly cover that later. But think of it this way. It provides connectivity to the sensors. It provides connectivity to the IoT devices. And you see there is something called MQTT. That's the protocol which is being used here to connect to the sensors. Is there any question on the phone? Okay, no question. So the left side, there are sensors which are connected to message site, which is able to retrieve data, store data, and pass command to the sensors. Message site, it provides the data to the enterprise. Somewhere the data can be stored, and you see everything on the right hand side, more of analytics software. Apart from, on top you see the image of a car. On the left side you see sensors sitting in the houses. On the right side you another example of data coming from connected vehicles or data coming from the mobile phone. And all this data gets stored locally, and you can do various type of analytics. So there's something under the car, there's something called infosphere stream, which can help you do real-time analytics. As the data come, analyze it. Where the car is now? Tell me now, immediately. Then there's something on the bottommost, you have got Informix warehouse accelerator, which provides in-memory analytics. It's not real-time. You have stored the data in memory, run some analytics on top of that. Then we have got, on top of Informix, we have got SPSS, which provides predictive analytics. And on top, you have got Big Insights, Hadoop-based analytics. And on the right-hand side, you see something called software and Bluemix. That's the cloud infrastructure. I'll cover that in detail in the second part of my presentation. In summary, for you to achieve an IoT application or to create an IoT application, you need a way to connect your sensor, and then you need a way to store the data and do analytics on top of that. And later I'll explain you how you need not get worried by the complexity of this slide. All this has been put on the cloud, so everything happens to you in the background. You don't even know what's happening. I'll show that. Moving on to the next slide. Oops, it's not moving. Yeah. I referred to MQTT earlier. So MQTT is the protocol. I would say it's the IoT protocol to connect your devices to wherever you want to. And why do we use MQTT, or why IBM uses MQTT for the IoT solution? the beauty of MQTT is it consumes very less battery, very less bandwidth. So the sensors, usually they are very resource constrained device. So you put a sensor in a well or in a bore well, or you put a sensor in the truck. It has got limited amount of battery power. It has got limited amount of bandwidth, and the network connection is not very reliable. So you need a way in which you can reliably transfer the data to the central server. Even if the network is not reliable, you see a lot of disconnection. You need a protocol which can ensure that once you submit a data, it will definitely get transmitted. Because you need something which is not very heavyweight. You don't want to transfer a lot of data and incur a lot of network costs. So MQTT, it can just support 2 bytes of data header, because it doesn't put too much in the data header. Just the payload takes whatever space it needs. So in summary, MQTT is the most suited protocol for IoT connection because it provides reliable delivery of data over unreliable network, and it is very conservative in terms of consuming the powers and the bandwidth, because usually the IoT devices are very resource constrained. And the other aspect of MQTT is it's an open source protocol. So if you have your own device and you want to use MQTT in your device, go ahead and use it without worrying about it being proprietary or you have to pay somebody if you want to use this protocol. This protocol was developed by IBM in 1994 along with Ireland, and we donated it to the MQTT open source community. It's part of the Eclipse Power project now, and there is a very strong ecosystem around MQTT. So you'll find a lot of open source clients for the devices which you want to connect to the internet. Next slide. So once you have a device, you need a way for the device to be able to connect to an MQTT server. Message site is one of the servers which I'm talking about. There are other servers available in the market which support MQTT. So what you really need a client which you can install on your device which can talk to the MQTT server. And the table here lists the various type of clients which are available for you to install on your client. So we have C, C++, we have got Java, JavaScript, and Lua and Python clients. I said these are the most popular languages, and we have got clients in all those languages. Next one. I mentioned this earlier when I was showing you that very big complicated diagram where the sensors are connecting to a device, and that device was message site. What is message site? It's actually an appliance. If you guys know about data power, it's something like that. If you know about WMQ, which is enterprise product, it is something like that. But the beauty here is, or the point to note here is, it's a very high performance internet scale device which can support millions of connections and millions of messages per second. The first few slides told you the amount of humongous amount of data and the humongous amount of connectivity which will be needed, because there are so many IoT devices in the world. So you really need an appliance which can connect to many devices, and it can support many or a very large number of messages. Message site does that. And most of the time, these IoT devices will not be within your enterprise. It will be beyond your firewall. So you need something which you can quickly deploy in the DMZ, so that you really don't have to worry about the security. The security is taken care by this appliance. Message site is something which can help you connect your IoT devices using MQTT protocol and help you retrieve data and send command to the IoT devices. Now that was the on-prem story. Those are the things which you need if you want to develop an IoT application on-prem. And fortunately, for me that part's too complicated. And when somebody talks to me like that, then I start wondering, oh man, so I need to go and buy all this software, I need to install all this software. No, you don't have to really do that if you want to use the cloud approach. Before I start talking about that, let me very quickly cover, in cloud there are 3 aspects. One is you have infrastructure as a service, in which you get the CPU, the storage, and the networking from the cloud. That's called infrastructure as a service. IBM offering there is software. And on top of that, we have got something called platform as a service. As the name implies, this is something which provides you a platform. So you go and you develop your application on that platform, you deploy on that platform without installing anything on your machine. So think of a scenario, you are developing a web application. Let's say you need an app server and you need a database facility. If you are doing it on your machine, you have to procure the machine, you have to set up the machine, you have to procure these two software, maybe Web3 Application Server and DB2 from IBM, install them, configure them, then you develop the application and deploy on top of VAS and DB2. What if we say you don't have to procure a hardware? So that's why you go to infrastructure as a service. And then you say, I don't even want to deploy the software. I just want somewhere where I can run my application. And the application should be able to run on the app server, and I need something to show the database. So I should have something which can provide me DB2 capabilities or the database capability. That facility is provided by PaaS platform. And the IBM offering there is Bluemix. Let me spend a few minutes on that. What Bluemix provides? It provides you a platform or the runtime of your choice. If you are writing an application in Java or Python or Node.js, you stick to your preference. And when you deploy on Bluemix, it will ensure that appropriate runtime is deployed, which is called build stack here, to execute your application. Then it provides some DevOps capabilities, which means you can develop your application as well as deploy it seamlessly. A topic in itself, so I will not go into details. Then it has got various APIs and services. I told you an example of service as a DB2 service. So you create an application which needs to store some data somewhere. You go to the PaaS platform and you bind to the DB2 service and you are ready to go. No more configuration needed. You can start saving and reading data from the database. It provides cloud integration. Many a times people don't want to move the data or application out of the enterprise, but at the same time, they want to develop innovative cloud applications which needs to access this data. Cloud integration provides you a way in which your application running on the cloud can access the data which is there in your enterprise without moving the data out of the firewall. And finally, the Bluemix platform, the Bluemix offering from IBM is built on top of the software offering which provides infrastructure as a service. I wanted to give an introduction to Bluemix because the demo which I'm going to show you, or the IoT application which I'm going to create, I'm going to do that on Bluemix. And the next slide shows you how to get the Bluemix ID. The Bluemix is in beta now, so you can go to that website www.bluemix.net and you can register to get an ID at no charge. Now, whatever the big diagram which I showed you, different offerings from IBM, we have put all those on cloud. So if you go to Bluemix, you can very quickly create your IoT application and deploy it on top of that. What it does, as the diagram says, it helps you to easily connect to the cloud, connect your IoT device to the cloud, and then you can collect the data from the IoT device, you can assemble the data to visualize it, and it also allows you to manage your IoT devices. So having all these things in the cloud, and it's actually in the software, with the infrastructure service, then you go and develop your IoT application on Bluemix, which can read all this data from the IoT cloud. When I take you the demo, it will become more clear what I'm saying now. So let's move forward. On this slide, there is a link which shows if you want to exploit these capabilities, where you should go. We have got something called IBM Internet of Things Cloud. Go there, very easy for you to connect your devices. Then we have something called device recipes. On the next slide, you will see the device recipes, which means that we provide you the code which you can deploy on your device so that you can connect to the IoT cloud in no time. Different devices are being supported now, and if you have developed any IoT application in the past, then you would be able to recognize with these devices. Intel Galileo, Texas Instrument, ARM, then Raspberry Pi. We have got ready-made client code for this. Get your device, attach a sensor to this device, put the code which you are providing, and boom, you are ready to connect to the IoT cloud. Apart from these devices, if you want to create one device, even that is possible. There are MQTT clients code available, deploy on top of that, you are ready to go. Now, for me to show you a demo using device becomes a little difficult. So the other option I have that instead of using a physical device, there is a concept of a simulator. I'm going to use that in the demo today. So you create a simulator comes with a device ID, and this simulator can simulate temperature or humidity or pressure. You pass this data to the IoT application, and you can do some analysis on top of that and take some action based on the data which you have received. So instead of really using the physical device in the development phase, I can go ahead and use the simulator and develop my application. And when I'm ready, I go and connect my device to my application. And finally, finally, on the bottom of the slide or the page, we have got something called Node-RED. I will cover that in slide detail in the next or succeeding slide. The next slide talks about, which I already hinted earlier, that IoT is available on Bluemix. And this we call, there is a concept of boilerplate. So when you go to Bluemix and you want to develop your application, and guys, I know this may get complicated, you may not fully comprehend it, but once you get the Bluemix ID and try it yourself, it will seem much, much simpler. So there is a concept in Bluemix which is called boilerplate. And I'm going to use that when I show you the demo. A boilerplate is a glue code which provides you a ready-built assembly of the most often used services. So when you want to develop an IoT application, you really need a time series database to do some analytics. You need an Internet of Things service to connect to your device, and you need Node-RED, which will essentially process the data which you get from the device and take action. When I go and create the application, I'll show you what a boilerplate is, but just remember, it gives you a glue code or readily assembled services which helps you to quickly develop your IoT application. The next slide shows Node-RED. It's a visual tool. I'll take this example. On the left-hand side, you see there's a number in blue. It's actually an IoT node. You drag and drop an IoT node in the studio, and you specify a device MAC address. You do that, and whatever data gets transmitted from a device, of course, you have to connect your device to the IoT cloud. Whatever device data gets transmitted from a device will get captured by this IoT node, the node in blue, which has got the MAC address. So once I have the temperature data, what do I do with that? The next one, I don't know what color is that, maybe orange color or the brown color, the temp node, that actually processes the data which it has received. It is going to extract the data and the temp threshold. It compares the data with the threshold data which you have defined. So if it goes above certain level, it says there is a danger, or it's in the safe limit, it says it's safe for you to do something. The demo which I'm going to show you will go in detail on how to create this Node-RED. But for the time being, remember, Node-RED is a way, is a wiring tool, is a visual wiring tool through which you can retrieve the data from your device, you can manipulate it, you can analyze it, and you can take some action. Okay, so we have reached towards the end of my talk. Now we'll look at the demo. And I will try to actually give you an online demo, but sometimes it doesn't work because of bandwidth speed. So what I thought, I'll also put some screenshots so that when I'm actually showing the demo, you can relate what I'm doing. And Apra is going to share with you the PDF file. So once you have your own Bluemix ID, just pick up the PDF file and you can do whatever I'm going to do now. Now the sample application, what it will do? It is going to collect sensor reading from a device. Instead of using a device, I'm going to use a simulator. I'm going to create an IoT application using the boilerplate on Bluemix, which is going to receive the data and process it. If the simulator shows the reading to be more than 50 degrees centigrade or less than 10 degrees centigrade, some action has to be taken. I can send an SMS, but setting that up was tedious. So what I'm going to do, I'm going to just tweet that message that the temperature has crossed the threshold. what it proves? It proves that you are able to read data from the device, you are able to do some analysis on the data which you have received, and based on your parameters, you are able to take action. And I'm sending a tweet message, which means I can do anything. If I can send a message to the internet, I can do anything, right? So that's what the demo is all about. Few slides. So IoT device simulator, that's the address where I will go and create a simulator for myself. And when you create this simulator, you don't do anything creative. When you go to that address, the simulator will be there for you. It comes with a unique device ID on the top right-hand side of the simulator. So you should note down that device ID. Then I'll go to Bluemix and create an IoT application using the boilerplate. When you create the application, let me move on to the next area. When I create the application, I'm going to specify a name to that application. And that's what you're going to use to invoke the application on the browser. Once I have specified the name and create the application, this is what I get. I get a Node.js application. I get a Node-RED, which I can use to create my own flow. Then I get, on the bottom you see there are two services. Just like I was mentioning, at DB2 as a service, there is an Internet of Things service, which helps you connect to your device. And there is a time series database, in which you can use your IoT data in a time series manner, which will help you in analyzing your data. So at this point, my IoT application has been deployed, but there is nothing in that. I just have all these services and the Node-RED with me. For me to do something useful out of that, I will go to the Node-RED, and this is the flow I'm going to create. I will not actually create this because I have written a script. I'm just going to import the script which will create this flow. You can as well create this from the scratch, or if you want, you can use the script which will be there in the PDF document which will be shared with you. So what happens here? On the left side, you see there is an IoT device node. There I'm going to specify the device ID, the simulator ID. I double click on the IoT device node and it will tell me where to put the device ID. That will receive the data from the simulator. The next node extracts the data from the payload and passes it on to the next node. And the next node analyzes the value. If it's below 6, it goes to low temperature. If it's below 50, it goes to the high temperature node. And from there, it goes to the Twitter node. And I'm going to configure my Twitter ID so that I can tweet. Whenever the threshold is exceeded, a tweet message will be sent out. So when you go to Node-RED, these are the pre-configured nodes for you. So instead of Twitter, you may have a Facebook node. So instead of sending to a tweet message, you can send it to Facebook. Or you may have a SMS node. Twilio is what we use to send SMS. Very, very interesting application. Have a look on Bluemix. Now, having this set up, I am going to decrease the temperature to below 10 degrees centigrade, and I will see that this event is getting published to my Twitter account. Let me go on to my browser. I will start sharing it. And if there is a delay, please interrupt me so I can give appropriate amount of pause. We have 50 minutes, so I think it will not take more than 10 minutes. We'll have 5 minutes, or if you are interested, I can stay back for Q&A session. Bear with me, it's very slow. I'm trying to share the browser. While I do that, any questions? Feel free to ask me questions, because there will be a delay whenever I am switching pages or invoking a command. So if you have any questions, feel free to ask me. Okay, I have started sharing. It may take few seconds for you to see the page. Anybody, please let me know if you are able to see my browser. Can anybody see my browser, please?
No, it hasn't come up yet. So it's just showing a blank screen. Nothing is coming up.
Let me see if I did something wrong. No, I have started sharing. It will just take some. It is very slow. I'm trying to log in into Bluemix, and even that is taking a lot of time. Folks on the call, has anybody developed any IoT application? Has anybody tried to connect a device as a hobby to the internet? Sargamani Luck, can you see it?
It is showing your meeting browser.
The screen came up, but then you changed to your...
Yeah.
You can see it now.
You can see the Bluemix page, login, right? I have logged into Bluemix. You can see the dashboard and few things.
Yeah, I can.
Okay. So guys, I just logged into my Bluemix environment and I go to catalog. Catalog has got everything which is there being offered by Bluemix. And I told earlier that this is a concept of boilerplate. I want to create an IoT application. So I go to IoT boilerplate, click on that. This thing comes up. It has got Node-RED. Please interrupt me if I'm going fast and it's not getting refreshed. So it has got three services. It has got Node-RED on the top leftmost, or the first service. Then it has got time series, and then it has got IoT. The Node-RED helps you create the flow, time series helps you store the data, and IoT helps you connect to the device. I'm going to create an application. At this point, I'll need to just specify a name. So what I will do, I'll just use my initials and say IoT. So I'm naming it VKS IoT. And I'll say create. In the background, on the PaaS platform, it's actually putting together all the three services and provisioning it in my organization. And these are terms which are used in Bluemix and used by Cloud Foundry. It will take some time. So while it's getting created, I will show you another page. So this is the page where I can get the IoT.
Now departing.
Mahendra.
Here is the IoT sensor, and then I have got my Twitter account open here. It's still creating. In the background, it's doing a lot of work. So sympathize with this person. He's actually doing all the things which you saw in my one slide, right? Message site, MQTT, and time series database. He's working hard now. Almost done. So here are the various applications. This is the one, VKS IoT, which I just deployed. I'm going to click on this. This will take me to the Node-RED page. On the Node-RED, I'm going to create a flow using the flow editor.
Vijay, has the page refreshed for other participants? Because we can still see that it is creating that create dialog.
Oh, you're still there? Okay, I moved 3 steps ahead of that. So what I have done, as I explained, create page, and then created something on the Bluemix. I created the link over there, and now I am on the Node-RED page. So I will wait here for it to get refreshed. This is an important step.
Okay.
Let me know when this gets refreshed at your end.
Sure.
So just recall the steps. What did I do? I logged into Bluemix. I went to IoT boilerplate. I clicked on that and I said create an application. I gave a name to the application. It got deployed. The name becomes your host. So using that name, I invoked something, and that took me to the Node-RED page. And I'm waiting at that page for it to get refreshed at your end. And what I'm going to do next, instead of creating that flow from the scratch, I already have a script. I'm just going to import that script, and the node will get created, or the flow will get created. Once I have that flow, on the first node, the IoT node, I will input the device ID of the sensor, which I showed you. You can go to the link and get the device ID. And at the other end, the Twitter node, I am going to put my Twitter ID, and it will ask me to authenticate myself. Having done that, I am now connected to the device at one end and to the internet, to the Twitter at the other end. I will go to the sensor and bring down the temperature below 10 degrees centigrade, and at that point of time, the data comes into this IoT. The nodes analyze that temperature has dropped below the threshold, and it sends it is the Twitter node that go and tweet this message. If you're tweeting, you could have as well connected this to your air conditioner saying that, okay, the temperature is too low, or maybe heater here. The temperature is too low, start the heater. And all this is captured step by step in the lab document, which will be shared with you. Go ahead and get your own Bluemix ID. Bluemix in beta now. Just specify your email ID and name, and you will have your own Bluemix ID. Use that, refer to the document, and create your own IoT application. And once you have this, maybe you want to experiment, get the real device, connect your real device to IoT, and then connect it to your car or to AC, whatever it is. I think that will be very exciting if you can do that. Can anybody see the browser, the refreshed page? Some bad luck today, too slow.
So I guess some people can see, maybe I'll try log out and log in again.
Okay, so if some people can see, then you can see there's a deploy button on top. On the right hand side, what I will do before doing that, this is the script which I have. I just put in a notepad so that I can copy and paste it. And I click here, I say import from clipboard, and I paste the information I have. Don't worry even if you can't see it, I'm just explaining what I am doing. So I already have the script which is in the PDF which will share with you. You import from the script and you have got the node. If anybody can see the node, just let me know. I did this demo before the election. It was not. I had the same problem. I thought Abki Baar Modi Sarkar may be lucky, but it seems not working. It's 12 o'clock, guys. If you can just hang on for 5 minutes, let's see.
Now departing.
Oh.
Himanshu.
Yes.
Basically, when I logged out and logged in, I can see that Node-RED page now with the deploy button and the flow.
Okay, so what I will do, I'm going to click on the IoT device, the very first node. Okay. When I click on that, a dialog comes up, and I'm going to give the simulator ID and say OK. That's all I need to do.
Okay.
Then I'm going to click on the rightmost node, which says tweet temperature alert. When I click on that, it says add new Twitter credential, where I'm going to give my Twitter ID. So when I do that, it actually takes me to Twitter page, and there is a way in which they authorize the app. So I'm going to say authorize the app. It will take me to the login page.
Now departing.
And then I can come back to my node. So what happens now, Twitter authorized this application to tweet on my behalf, right? And after that, I come back to Node-RED and I say, okay, my flow is ready. I have got my Twitter account open, and you see, I don't know whether you can see, but there is no temperature message here. I will go to the sensor, decrease the message below 10 degrees centigrade, and see whether something gets tweeted to my account. Oh, sorry, I always make this mistake. After having made all the changes there, I need to deploy this node. Otherwise, nothing will work. So I have deployed it. I have to go to sensor again and then manipulate the temperature. Yeah, so if you can see the Twitter page, let me increase the temperature, otherwise it keeps emitting this information every 2 seconds. So a lot of tweet messages will come. If you can see my browser, I am into my Twitter account, and you see there are 2 tweet messages saying there are low temperature. Can anybody see my Twitter page? Okay. You cannot see that the network is bad, and very sorry for that. But this is what the whole flow was. You connected your device. Instead of using a device, you use a simulator to connect to IoT Cloud, IBM IoT Cloud. And you went to Bluemix. You created an IoT application. You created a Node-RED flow. On the IoT node, you specify the address of the device. It gets the data, processes it, and based on your logic, high temperature, low temperature, you use the IoT node to actually tweet it to the defined user ID. That's all it does. And you did this, you can actually do this in less than 10 minutes. Get the Bluemix ID, get the PDF document which illustrates the lab, just follow the instruction, you can do it. Even if you don't get the PDF document, go and play around with Node-RED and with IoT. Very exciting. I think that's all I had today. If there are any questions, I would be happy to answer. I know we are running late by 3 minutes.
Now departing.